Our next topic is all about the integration of hyperbolic functions. No, okay. So this would be the sum formulas of hyperbolic functions. So first is the integral of sine h u du is equals to cosine h u plus c. Okay, so second is the integral of cosine h u du is equals to sine h u plus c. The next is the integral of tan h u du is equals to ln cos hu plus c. Then the integral of cot u du is equals to ln sin hu plus c. Then another is the integral of secant u du is equals to tan inverse sin hu plus c. Then another is the integral of cosecant hu du is equals to ln the absolute value of tan hu over 2. No? This formula of the integration of hyperbolic functions so can be applied to our example. No? Okay, so for example number 1, if you have given the integral, no, which is the integral of sine h quantity of ln x over x dx. So find the antiderivative of that. Okay, so take note our equivalent u that is equals to ln x. Then we have du here that is equals to the 1 over x dx. So where dx here that is equals to x du. Okay, then we can now change the given. So which is the integral of sine h. We change ln x into u, no? Then we have over x here, then dx that is equivalent to x du, so that we can cancel x here. So therefore the integral of sine hu du. Okay, so as you can see the formula, sine or the integral of sine hu du that is equals to cos h or cosine hu plus c. No? So this would be equal to cos u then plus c. Okay, substitute the equivalent or which is the equivalent variable of u, no, ln x. So this would be cosine h ln x, no, then plus c. Okay, so this would be the final answer. Then another problem, number 2. So what is the equivalent of cos or cosine h quantity of ln x squared then ln x dx over x? Okay, so let's say u here that is equals to ln squared x, or that is equals to the quantity of ln x then square. Okay, so therefore du here, okay, in this case of or the equivalent of u, when you derive, take note, we can apply here chain rule, no? Okay, so we have derived first from outside, which is 2 times the ln x. Okay, then the derivative of the inside, which is ln x, or the derivative of ln x, so that is equals to 1 over x. Then we have dx here. Okay, then where dx, so that is equals to x du over 2 ln x. Again, we change the problem given. So the integral of cos or cosine h u, then we have ln x, then where dx that is equals to x du over 2 ln x here. By the way, we have x here. Okay, so next is we can now cancel x here, then also ln x, then ln x, no? So therefore we can obtain the 1/2 the integral of cosine h u du. Okay, so we all know that the equivalent of cos hu du is equals to sine hu plus c. Okay, so therefore this is 1/2 sine hu then plus c. Okay, so this would be 1/2. Then substitute the equivalent value of u, no? So which as the ln squared x. Okay, so we have sine h then ln squared x then plus c. Okay, so this would be the final answer. So another in problem given number 3. So what is the equivalent of the integral, or what is the equivalent of the antiderivative of the integral of tan h quantity of 8x dx, no? So let's say u here that is equals to 8x, then du here that is equals to 8 dx, and where dx here that is equals to du over 8. Okay, so therefore the integral of the tan h u, then we have dx equivalent is du over 8, or the integral of, or 1 over 8, the integral of tan hu then du. Okay, so again, by the way, the equivalent of the integral tan hu du is equals to ln cosine hu plus c. So this would be equals to 1 over 8, then ln cos hu then plus c. Then substitute the equivalent of u, which is 8x, no? So therefore 1 over 8 ln cos 8 then 8x then plus c. So this would be the final answer. So another is, what is the equivalent of the integral of x e to the power x squared cos h quantity of e to the power x squared dx. Okay, so in this case, this problem is a little bit difficult, no? But if you solve this kind of problem, then you know the process of solving in derivatives, no? Or how to integrate, no? Then for you, it would be AC, no? Okay, so in this case, let's say u here that is equals to e to the power x squared, then du here that is equals to e to the power x squared, and the derivative of x squared that is equals to 2x, then dx. So where dx here that is equals to du over e to the power x squared times 2x. Then we can now substitute or change the problem given, no? Then we have in the integral of x to the power x squared, then cos h u. So where dx here that is equivalent to du over e to the power x squared times 2x. So therefore, we can now cancel x here, and then e to the power x squared. So this would be cancelled out. So the remaining is 1/2 the integral of cos hu then du. So take note, the integral of cos hu du that is equals to ln sine hu plus c. Okay, so this would be 1/2 ln sine hu then plus c. Then substitute the equivalent of u, so which as e to the power x squared. So 1/2 ln then sine h then e to the power x squared then plus c. Again, this would be the final answer to this problem given, or the equivalent of antiderivatives. So another, what is the equivalent, the integral or the equivalent antiderivatives of the integral of quantity x minus 10 to the power 9, second h, the quantity of 4x squared minus 8x to the power 10 dx. Okay, so let's say u that is equals to 4x squared minus 8x to the power 10. Then we can now derive, no? So du here, that is equals to 8x, then minus the derivative of 8x to the power 10, that is equals to 80x to the power 9, then dx. So, or du here, that is equals to 8 times x minus 10x to the power 9, then dx. Okay, so where dx here, that is equals to the du over 8 times the x minus 10 to the power, or x minus 10x to the power 9. No? We change this given. So we have the integral of the quantity of x minus 10 to the 10x to the power 9. No? Then we have second h, then I change this u, then dx here, that is equivalent to du over 8x minus 10x to the power 9. So again, as you can see the problem given, so this would be cancelled out. So therefore 1 over 8, the integral of second h u, then du. Okay. So again, the equivalent of the integral of second hu du is equals to tan inverse sine hu plus c. So this would be 1 over 8 tan inverse, then sine hu, then plus c. Substitute the equivalent value of u. So this would be equal to 1 over 8, then tan inverse, the quantity of sine h, then where u, that is equivalent to 4x squared minus 8 to the power, 8x to the power 10. Okay. So plus c. So that is the final answer. Okay, so problem number 6. What is the equivalent antiderivative of this given, no? Which is the integral of the quantity of x times the quantity of x squared e to the power x power minus 1. Then we cosecant h, then quantity of e to the power x to the fourth, no? Minus 2x squared dx. Okay, so by the way, I let u here that is equals to e x to the power 4, then minus 2x squared. What is the derivative of e to the power x to the power 4, no? So we have here e to the power x to the power 4. Then we can now apply chain rule here. So we can also derive the x to the power 4, no? So which is the equivalent of 4x cubed. Then the derivative of 2x squared. So this can be 4x. Then we have dx. Then where dx, that is equals to the du over 4x cubed, then a to the power x to the power 4, no? Then minus 4x, or dx also is equals to the du over 4 times the quantity of x cubed then a to the powered x to the powered 4, then minus x. Okay. Again, we can now substitute the equivalent of u and the x, no, for the problem given. So this would be the integral of x times the quantity of x squared, a to the powered x to the powered 4, then minus x, then cosecant times the cosecant h, or cosecant hyperbolic, no? So which is u. So again, I change this into u, no? Then where dx here, that is equals to du over 4 times the quantity of x cubed, then e to the powered x to the powered 4, then minus x. Okay. So as you can see, that this problem given, when you distribute this x, so again, by the way, this is 1. Okay. So take note of 1 na siya. Okay. So I distribute x into here. Okay. So this would be the quantity of x cubed, then a to the powered x to the powered 4, then minus x, then cosecant h u, then du over 4 quantity of x cubed, a to the powered x to the powered 4, then minus x. So by the way, this would be cancelled out. Okay. So therefore, we have 1/4. Then the integral of a cosecant h u and du. Okay. So as you can see the formula, the equivalent of cosecant h u du, or the integral of cosecant h u du, no, that is equals to ln the absolute value of tan h u over 2. So this would be 1/4, then ln, then tan h u over 2. Okay. Then plus c. So substitute the equivalent value of u, no, which is e to the power x4 minus 2x squared. So therefore 1/4. Then we have L in, then tan h, then times the e to the powered x to the powered 4, then minus 2x squared. Okay, 2x squared. Then over 2. So then plus c. Okay, so this would be the final answer.